Hey, what's going on, everyone? In this video, what we're going to be talking about is two-dimensional projectile motion. And what we're going to try to do is we're going to try to answer two specific questions. The first question is, what is projectile motion? And the second question is, how do we solve a projectile motion problem? So, what is projectile motion exactly? Projectile motion is when a particle is launched with a certain velocity v0 at a certain angle theta, and throughout the particle's trajectory is affected by only one force, and that force is the force of gravity. So it experiences an acceleration due to gravity whose magnitude is g. So if you take a look over here, you see that the some of the parameters on the diagram are defined over here. So y0 is the initial height. G is the gravitational acceleration, which is 9.81 meters per second squared. X is the horizontal landing distance of the particle. And v0 is the initial velocity of the particle. Theta is the angle at which the projectile is launched. So the projectile is the object. Now, projectile motion is a combination of two types of motion. The first type is free fall motion. So the particle experiences free fall in the y direction. Now keep in mind, even though the particle might be ascending or its y distance might be increasing or its height might be increasing, the particle is really in free fall motion because it experiences an acceleration downwards due to gravity. So eventually this particle is going to fall back down to the ground. The second type of motion is constant velocity motion, and it experiences this type of motion in the x direction. The reason is because the particle doesn't experience any acceleration in the horizontal direction. So its velocity, whatever initial horizontal velocity that it was given in the x direction, remains constant and doesn't change. So the second question here is, how do we solve a projectile motion problem? So the way we solve this kind of problem is by recognizing that the particle is really performing two types of motions. The first type of motion is horizontal displacement, and the second type is a vertical displacement. For the vertical displacement, the particle experiences an acceleration due to gravity in the downwards direction. So we have to apply the free fall equation for the y parameters of the particle. Whereas for the x parameters, we apply only constant velocity equation. So you see here that for the free fall equation, we have our first equation that describes the y velocity of the particle. So you have v sub y is equal to v0y minus gt. Now v0y is the initial velocity of the particle in the y direction. Okay, so here you have y represents the height of the particle, and the equation for the height of the particle is described here. Of course, you have the other dependent equations that you can derive from these two independent equations. You have a third equation here, minus 2g times y minus y0 is equal to vy squared minus v0y squared. And there's a fourth equation, but we won't get into that. We'll just keep it simple for now and just focus on these three equations for the free fall. For the constant velocity equation, it's very simple. You have one equation to deal with, and this equation is simply x equals v0xt plus x0. v0x is just the initial velocity of the particle in the x direction. Okay, so let's take a closer look at this particle when it's first launched. So when the particle is first launched, it's given an initial velocity v0 at an angle theta. Okay, now v0 is a vector, and v0 can be written in the ij notation as v0 cosine of theta in the I direction plus v0 sine of theta in the j direction. V0 cosine of theta is V0x, right? The initial velocity in the x direction. This is because the vector V0 has been decomposed into two components. You have the x component of V0, which is V0x, and then you have the y component of V0, which is V0y. And when you decompose them, you get these two, V0 cosine theta and V0 sine theta. Okay. Now V0 is the speed at which the particle is launched. Okay. So there's a difference between velocity and speed. Speed is the magnitude of the velocity. So you get the speed by taking the components of the velocity, squaring them, and then adding them, and then taking the square root. And this will provide you the speed in the theta direction that the particle was launched. Okay, so this was just meant to be a quick video to give you a brief introduction into two-dimensional projectile motion. And what we're going to do is we're going to look at a few examples in the following videos on projectile motion and how to solve two-dimensional projectile motion problems.